I am learning Hammer right now, and I just have these stupid little ideas that I want to try out, and I thought, why not show it on YouTube? And that's why we talk about image tiling today. The solution to a problem nobody really has. But it's fun anyway, so what's image tiling? First, what it is not. It's not the same as texture tiling. It is related to it, but it kind of works the other way around, I guess. So for texture tiling, you take a seamless texture and then put it on a surface and it looks like a continuous image of, let's say, tiles or wood or concrete or whatever. It's very easy to cover a lot of surface with a small texture. Image tiling, however, instead of having the same texture spread seamless over a surface, tries to have multiple unique textures that then look like one seamless image. You can imagine it like a puzzle, like a full image that you cut into pieces and then put back together afterwards to make it appear that all these pieces together, all these tiles, look like one image again. But why would you need that? Let me show you. In Source, the default textures the game comes with are 256 by 256 pixels or 512 by 512, or maybe there is a 128 by 128 in the mix. They look shit. If you convert your own custom textures that you find on free or paid texture sites, you can choose between different texture resolutions, which most of the time starts at 1024 by 1024 pixels. Then you got 2K resolution, 4K resolution, and 8K resolution. But as you can see, Source isn't having it. 4K is the maximum resolution that it accepts for a single texture. And for the most use cases, this is absolutely sufficient. And you could argue for really all use cases. But what if not? What if you have a rare case where the original resolution is over 4K and you need to get it in the game without setting for lower resolution? Well, the answer is image tiling, obviously. For an example, let's take this picture I had laying around. It is 16K by 8K. If you want that image displayed big in your map and in a prominent position, you will need it in that very high resolution. Okay, so how do you get it into the game? First, we need to make the tile. So let's load it into Photoshop. You could tile it yourself by using the crop tool, but that sounds like a terrible time, so I rather use a script that does all the work for me. Now we have 8 tiles, each of the tile is 4096 by 4096 pixels in resolution. Perfect. We now need to convert the JPEG to a format Source can handle, which is the VTF format. The VMT editor tool has a batch convert feature that does just that. When setting this up, we need, and that is very important, under flags, to check point sample. If that is not checked, there will be clearly visible edges between the single tile pieces later in the game. Now for Source to be able to handle the VTFs, it also needs VMTs, which are basically just text documents that tell the engine where the picture is located. Fortunately, VMT Editor has also a batch VMT generator that does that for us as well. Okay, so now let's open Hammer and load the map that you would like to improve with your beautiful image. We have 8 tiles, therefore we make 8 blocks with the side the picture is supposed to be on, square. And then just apply the single textures to the correct squares, select all and press around in the texture tool until it looks as it should. And that's it. Now everybody can appreciate the beauty of your art, even from miles away. You can play the map and fly beside the image, take a real close look, get really close to it. It will look perfectly sharp. However, what if you are a huge classic arts fan? Not just merely doing stuff in Blender and rendering it out, but what if you are dealing with a timeless masterpiece, where it would literally hurt you to lose any of that beautiful resolution? So basically what I'm saying is, how far can we push this? Let's see. We need to first find an image with insane resolution and then a way to actually download it. I tried a bunch of stuff out, so let me save us a lot of boring explanation here and jump straight to a workflow that actually works. So getting your hands on high resolution pictures is actually not that easy, but luckily some years ago Google made or facilitated or caused, I'm not sure what role Google played exactly, but at the end of the day a lot of museums all over the world made gigapixel scans of some of their most famous paintings. The resulting photos can be seen on Google Arts and Culture in a section they call Art Camera. It's pretty cool as it explains some details and gives you background info and whatnot. However, there's also the painting as a zoomable image. How zoomable images work is that there are multiple images of that same painting with increasing resolution layered on top of each other. And depending on the user's zoom level, the necessary resolution will be loaded in. Thanks to my abysmal German internet, you can actually lean back and watch how these zoom levels load in. But there is no right-click option. No way for us to just download it straight from here. Instead, we will use a tool called the Zoomify RS, which is in the spirit but not connected to the original browser, the Zoomify tool. So we copy the link to the Arts and Culture page into the Zoomify RS, which will scan for a zoomable image and lists all the different resolution layers that image provides. For this example, I choose Rembrandt's The Night Watch because it's good looking and it's the biggest photo Google Arts and Culture has. It comes in at 112,517 times 93,342 pixels. After the download is complete, we can proceed the exact same way as we did with the Solas picture from before. One thing to note in Photoshop: Valve really likes square textures. But because the original resolution is not perfectly dividable by 4096, the yellow stuff you see there is called padding. It fills out the last tile to also be 4096 pixels wide. And same goes for the vertical resolution. Another thing to notice, in VMT Editor, converting 4K images to VTFs takes surprisingly long. The tool can convert about 3 images per minute. For the Night Watcher's 644 tiles, it took my PC around 3.5 hours. On the other side, the VMT creation is still instant. So for the hammer part, it would take ages to create all the blocks and especially applying all the textures by hand. And so once again, a nice little script, this time in Python and using the PyVMF library by GoRange Ninja, we can automate that process as well. Just fill out the size of each tile in hammer units, meaning the size of the geometry, not the resolution of the texture tile, the number of vertical and horizontal tiles, the folder with all the textures, and the output name of the map. Now we can open Hammer, select all, press around again, and there it is. An almost 400-year-old masterpiece coming to life in your map in ultra sharp 12 billion pixels. Well done. But is that really as big as it gets? Theoretically, no. In practice, it's already way too big. And let me show you why. I increased the cube size so the picture covers almost the whole grid now and then put it next to air control, as I thought it would be funny to look out of one of these windows and see a big ass painting. But see if you can spot the moment when all the textures are getting loaded in. Exactly. In-game, I might have 5 FPS, but OBS was recording with maybe 5 FP minutes. Because loading and displaying 644 4K textures at the same time in an engine from over 20 years ago simply didn't leave enough resources for OBS to record properly, and not enough for the game to run properly either. The game, pushed pretty hard already, also can't care for point sampling anymore, and clear lines show between some but not all tiles. But that's for the effective limitations. Mathematically, however, if I open my Google Chrome and I do square root of 961, which is the effective maximum number of unique textures in a single map, squared times, what was it, 4096 squared, Then we get 16.1 billion pixels. That will lag your PC badly, my buddy. Ooh, that would be a big picture right there.